Welcome to this tutorial, guys. Basically, I'm going to cover trigonometric identities. In an exam kind of situation, trig identities basically come up as proofs. So you have to prove a certain identity. Okay, so the way that you start doing this is you first draw a diagram. Okay, let's try drawing this nicely. Okay, so we got a circle, great, but it's very off center. Let's see. Okay, so let's just say that's the center of my circle, and there we have a nice set of axes. Okay, then now we draw in our triangle. There we go, and we've got our 90-degree triangle. Oh no, let's take that out as well. Great. Okay, so let's get our 90-degree triangle in. Okay, good stuff. Okay, and we've got our R, we've got our X on this axis, and our Y on this axis, and here is our theta. Okay, this should be the start of any problem. Okay, so once we have that, we basically know everything we need. So we can go on to some questions. Okay, so I'll draw this diagram and then try these questions together. Okay, so basically we have to prove that, okay, let's get these out the way as well. Okay, so sine theta in terms of x and y is equal to y over r. That's just opposite over hypotenuse. So this is your opposite in that case. Okay, next we're going to do cos theta is equal to x over r, and tan theta is equal to opposite. So we're looking at this angle. Opposite is y over x. And then the opposite of this, or the 1 over cos, is equal to cosec theta, which is 1 over cos, so it's going to be r over y. Sec theta is equal to r over x, and cot theta is equal to x over y. Okay, so these you should be able, or you should learn them, and you should be able to pretty much write them on demand. Okay, now we can get into the question. Okay, so how we prove something is we first work with the left hand side or the right hand side, and we work with them separately. So the left hand side of this equation is equal to sine theta, which is equal to y over r. We can't do much more there, so we work with the right hand side. So the right hand side is equal to 1 over cosec theta, which is equal to 1 over, now cosec theta is r over y. Okay, and then that's 1 over y over r. So what we can see is that therefore our left hand side equals our right hand side, and so we have proven the identity. Okay, so you basically go about every single question like that. So let's see. Our left hand side is equal to sec, which is r over x, and we can't do much more with that, so we work on our right hand side, which is equal to 1 over cos theta, which is equal to 1 over x over r, which is equal to r over x. So again, we've shown that our left hand side is equal to our right hand side, so the identity is proven. Okay, working with tan. So our left hand side is equal to tan theta, which is equal to y over x, and our right hand side is equal to sine theta over cos theta, which is equal to y over r divided by x over r, which is equal to y over r times r over x. These two cancel, so we have y over x. So our left hand side equals our right hand side, and therefore it is proven. Okay, so I'm sure you guys can see a bit of a trend. It's pretty easy. You're just proving things. Okay, so now we have sine squared plus cos squared equals 1. So we have to prove this. So on the left hand side, when I say left hand side, obviously I mean on the left hand side of this equal sign, just in case. Okay, so the left hand side equals sine squared theta plus cos squared theta, and our right hand side equals 1. So what is sine squared theta? Sine is y over r squared plus x over r squared. So we have y squared over r squared plus x squared over r squared equals x squared plus y squared over r squared. Okay, so we aren't done yet, but if we look at our triangle that we've been using, okay, we know that from Pythagoras, we know that the hypotenuse of your r squared equals x squared plus y squared. So we can say that. But from Pythagoras, we know that x squared plus y squared equals r squared. Therefore, we have r squared over r squared. So what I've done is I've replaced x squared plus r squared, x squared plus y squared by r squared. And r squared over r squared is just equal to 1. So therefore, the left hand side is equal to our right hand side. Cool stuff. Okay, let's go on. Let's try a different one. So we have 1 plus tan squared theta is equal to, let's see, 1 plus tan squared theta is equal to sec squared theta. So if we work with our left hand side, we have 1, okay, let's actually, okay, so we have 1 plus tan squared theta, which is equal to 1 plus sine squared theta over cos squared theta, which is equal to sine squared theta plus cos squared theta all over cos squared theta. But we know that sine squared theta plus cos squared theta is equal to 1. So this new term becomes 1 over cos squared theta. Okay, so that's cool. Okay, let's continue from there. And this can be rewritten as 1 over cos theta squared. And 1 is 1 over cos theta. We know that that is sec theta squared, which is equal to sec squared theta. And our right hand side is equal to sec squared theta. So we've proven that the left hand side is equal to the right hand side. Okay, let's go on to one more example. So let's say cosec squared theta minus cot squared theta is equal to 1. Okay, so how can we break down cosec? So cosec is 1 over sine, but it's cosec squared, so it's going to be sine squared theta minus, okay, so cot we can say, let's see right here, okay, so we know that tan theta equals sine theta over cos theta, and we proved that right here, and therefore cot theta equals cos theta over sine theta. So using that, we have cot squared being we have cot squared being cos squared theta over sine squared theta, which is, okay, so this is our left hand side. Okay, and then we can say this is equal to 1 minus cos squared theta over sine squared theta. Okay, but we know that sine squared theta plus cos squared theta equals 1. Therefore, moving this to that side, we have sine squared theta equals 1 minus cos squared theta. which is right here. So we can replace the 1 minus cos squared with sine squared theta over sine squared theta, and these cancel, and the answer is 1. And our right hand side on this equation is equal to 1. Therefore, the left hand side is equal to the right hand side. And that is our answer. Okay. Okay, so yeah, these identities are important, and it's also important that we're able to see them when they're written in other ways. For example, this can be written as cos squared theta equals 1 minus sine squared theta. That came useful before that. In the question before, we can see that this can be written as, let's put a 1 by itself, so sec squared theta minus tan squared theta equals 1. Yeah, and let's have this one. This one can be written as, let's say, cosec squared theta minus 1 equals cot squared theta. So we're able to write these identities in different ways. Yeah, so that's basically identities, just proving some of them. There's a lot more that we can prove, but all of them follow the same logic. We just write the left-hand side, get it to as far as down as we can, and see if it matches the right-hand side. If not, then we work with the right-hand side. So I hope this video helped, guys. Yeah, thanks for watching.